In these examples, we're going to look at solving equations using substitution, and these equations, when we use substitution, will be quadratic in form. So remember, when we solved quadratic equations in previous lessons, it looked like this. So we had a quadratic equation, and we had ax squared plus bx plus c equals 0. So that was the form of a quadratic equation. So when we solve these problems, for example, the first one I'm going to look at, when we look at this one, it looks pretty complicated as it is, but it really is not, because once we use that substitution, we're going to get a very nice quadratic equation that's going to be in this form, and it'll be easy to factor. So the examples we're going to use will be factorable. Okay, so let's look at the first one. And so notice, I want you to notice that if you look at what's being squared here, you have this rational expression, 1 divided by x plus 2. You also see it here in the term where this rational expression is being raised to the first power. So the idea is this: when using substitution, and many times you have to look, or almost all times you have to look at what you have, and very easily, once you're efficient at this, very easily determine what u should be. So we're going to change the variables now to the variable u. So we have u equal, and we're going to let u equal this rational expression right here, because I see it here, and it's being squared, and I see it here, and it's being raised to the first power. So if I let u equal this, 1 divided by x plus 2, notice what happens. It becomes very easy to see that you're going to get a quadratic equation that's quadratic in form. So wherever we see this expression, I'm going to substitute the variable u. So I get 5u squared minus 3u minus 2 equal 0. So notice wherever I saw that expression, I substituted the variable u. Okay? Now, this right here, notice that this is quadratic. This is now a quadratic equation, right? So I have this quadratic equation, which is factorable. So I'm going to go ahead and factor it. And so when I factor this, I'm going to factor it as 5u, u, and then we're going to need the 2 to be here and the 1 to be here. The last sign is negative, so these signs have to be different. And I need the middle term to be a negative 3u. And so the only way that can happen is if this 1's negative and the 2 is positive. All right, so let's double check. So the outer is negative 5u, the inner is a positive 2u, and when I add them up, I get negative 3u. Okay, so I factored this correctly, and now I'm going to set each factor equal to 0 using the zero factor property. So I get 5u plus 2 equals 0, u minus 1 equals 0. So once we got to this point, the rest is very easy for you because you've done this before. You've solved quadratic equations by factoring many times in previous lessons. And so at this point, I have two linear equations. So I'm going to solve each of those linear equations. So I get 5u equals a negative 2, and dividing both sides by 5, I get u to be a negative 2/5. All right, and over here, solving this linear equation, that's easy. So u equals 1. Now be careful. These right here are solutions to this quadratic equation with the variable u, right? But remember, my original equation did not have the variable u, it had the variable x. So I got to solve for x now. And so that's easy to do. Watch how easy this is. So now remember, you have u equals these two numbers, negative 2/5 and 1. So you got to now solve for the variable x. So you got to go back here, and in place of u, remember in place of 1 over x plus 2, you substitute u. So you're going to resubstitute this time. So u is 1 over x plus 2, and that's going to equal negative 2/5. And over the same thing here, remember you have two solutions here. So u is 1 divided by x plus 2 equal 1. Okay, so notice now I have these two equations, okay, and I have the variable x now. So once I solve for the variable x, I'm going to get the solutions to the original equation. Okay, so you got to remember some things in the past. So remember, one of the things you had to remember was how to factor or how to solve a quadratic equation by factoring. Now you have to remember from previous lessons or in previous courses how to solve how to solve an equation that's a rational equation. And in this case, it's a proportion. You have a ratio equal to a ratio. And it's very easy to solve a proportion. All you do is cross multiply. Same thing here, cross multiply. All right. And the other way you remember how to do this is to multiply both sides by the least common denominator, which in this case will be 5 times x plus 2, and over here will be x plus 2. All right, so just remember these things from previous lessons. It does help you to get through many of these problems, just those prerequisite skills that you've had in the past. But we have a proportion here, so I'm just going to go ahead and cross multiply, just like this. And so I'm going to go ahead and do this first. So I have negative 2 times x plus 2, just like this, equal, and then 1 times 5. Okay? And so I get this. Now, just want to just to remind you something. So I'm going to go back here just to remind you about another prerequisite skill that you learned. So right here, the original equation, 1 divided by x plus 2 equal negative 2/5. So remember, you also learned how to solve a rational equation by multiplying both sides by the least common denominator. And the denominator here is x plus 2. The denominator here is 5. So my least common denominator would be 5 times x plus 2. Once you find the least common denominator, you're going to multiply both sides by that least common denominator. And I want you to see what's going to happen. So I'm going to multiply the left side by the least common denominator. And I'm going to multiply the right side by the least common denominator as well. And once I reduce these x plus 2's, these factors divide out, and these factors divide out. I want you to see what happens. I have 5 times 1 times 1, which is 5, equals negative 2 times 1 times x plus 2, which is negative 2 times x plus 2. And what you see here is this. Okay? So the point being that once you get to this step, if you have a proportion, you can easily solve this proportion by cross multiplying. You do not have to go through the process of finding the least common denominator. Okay, so I'm going to go ahead and continue this one right here. So I'm going to go ahead and distribute the negative 2. So I get negative 2x minus 4 equal 5. Adding 4 to both sides, I get negative 2x equal 9. And solving for x, I'm going to divide both sides by negative 2. And so negative 2 divided by negative 2 is 1. 1 times x is x. So I get x to be a negative 9/2. Okay? Now, just to remind you about something. So remember when you solved a rational equation, you also had to look at your restrictions. Remember that? And so the restriction here, what's going to make this denominator 0 is when x is negative 2. So my restrictions is that x cannot equal negative 2. The point is this. So when you solve for the variable x, you just have to make sure. See, your original equation had a fraction, right? And in that denominator, you had the variable x. So the only value of x that makes this undefined, that makes that denominator 0, is negative 2. So if you don't get negative 2, you're fine. As long as every step here is correct, and this is not a restriction, then this will be a solution. Let's do the same thing here. Now for this one, remember most of you, when you look at this, you prefer to have a fraction here just like you had here. And that's fine. You just have to do this. You have to say x plus 2 equal 1 divided by 1. And then we cross multiply. So x plus 2 times 1 is x plus 2. And then 1 times 1 is 1. And then subtracting 2 from both sides, I get x equals, this is 0. And 1 and negative 2 is a negative 1. And negative 1 does not make this fraction, neither of these fractions, undefined. And so there's the other solution. All right, it's a very simple process. So there are many equations where it is so much easier to use a substitution to solve that equation. And here's an example. So let's look at example 2. So in example 2, we have this equation. Okay, so let's get another sheet of paper. So here's the equation. So example 2, you have y to the 2/3 minus 15y y to the 1/3. I'm sorry, that's 30 y to the 2/3 minus 15 y to the 1/3 equals 0. Okay, so notice that for most of you, this looks pretty complicated. And so if I can get this to be a quadratic equation, then this may be an easy equation to solve. Okay, so here's the idea. So don't make this complicated. It's fairly easy to deal with. Many times, the way I would approach this is to look at that term that's right after that first term. So here's my first term. Here's my second term. And you see this variable expression right here. Just look at this one right here. Just look at this. So this right here, chances are if you let u equal y to the 2/3, okay, I'm sorry, y to the 1/3, excuse me, y to the 1/3, and then remember you're trying to get a quadratic equation, right? So you want the first term to be something raised to the second power. So what I'm going to do now is I'm going to square both sides. So I'm going to go ahead and rewrite this over. So once you let u equal this, I'm going to go ahead and rewrite this over. Now you're going to square both sides just like this. And notice what happens. I'm sorry, that's squared right here. Notice what happens. U squared equals, and then remember one of your properties when you have a power raised to power, remember the power rule for exponents, when you have a power raised to power, you multiply those exponents. So the power of a power rule. You multiply exponents. So this becomes y 1/3 times 2 is 2/3. And notice this right here is this, right? So now we're going to substitute. We're going to change the variable y to the variable u now. So get 30. This right here, remember that's y to the 2/3, which we now know is u squared. So 30 u squared minus 15, and then y to the 1/3, remember, is u, equal 0. All right, so now I went from an equation that looked complicated to a quadratic equation. Now to solve this quadratic equation, remember in this one here, we went ahead and factored, right, into two binomials. Here though, remember what you want to do is look for GCF. And we should have, in this case, look for GCF here, but the GCF here is 1. And so here, though, it's not. The GCF here is 15u. So we're going to go ahead and factor out a 15u. And when I factor out a 15u, 15u times 2u is 30u squared minus. And then 15u times 1 is 15u equals 0. All right, so I factored this quadratic equation by first factoring out a GCF, and so that's what I get. So I'm going to set each of those factors equal to 0. So I get 15u equals 0, 2u minus 1 equals 0, and I'm going to solve each of those linear equations. So 15u equals 0, remember to get u by itself, we're going to divide both sides by 15. 15 divided by 15 is 1, 1 times u is u, and then 0 divided by 15 is 0. So I get u to be 0. Over here, adding 1 to both sides, I get 2u equal 1, dividing by 2, the 2's divide out here, so you get u equal 1/2. Now just as the previous problem, remember you solve for u, right? That's this equation right here, but remember your original equation had the variable y. So now you have to solve for the variable y now. Okay, so now we're going to go back and resubstitute. So remember what we let u equal. Remember u was y to the 1/3. So I'm going to come back and resubstitute. So now I get y to the 1/3 equals 0, and y to the 1/3 equal 1/2. Okay. All right. Now we got to remember some things from a previous course. So there are two ways, and you need to look at this in both ways as well. So one of the, in a previous course, when you looked at rational exponents, one of the things you learned, one of the concepts you learned was how to look at rational exponents. See, a to the 1 divided by n. So a to the 1 divided by n was defined to be the nth root. So remember, your index is n here. Your denominator is your index. The nth root of a. All right, and so using this idea here, I know this. So So there are two ways you can think of this. So let's think of this as this. So y to the 1/3 by a previous course means the cube root of y, right? The cube root of y equals 0. And then remember, when solving a radical equation, I'm going to go ahead and rewrite this over. When solving a radical equation, you raise both sides to the power that's equal to the index. So if my index is 3, I'm going to raise both sides to the third power. And so the cube root of y cubed, the cube root and the exponent 3 undo each other. So you get y to be, and then 0 to the third is 0. Okay? Now here's what I also want you to remember as well. So one of the other things you learned was this. All right, I'm going to go ahead and rewrite this over. All right, so one of the other things you learned was this. So one way you need to think about this, and you got to be able to think both ways, is to rewrite this rational exponent as a radical using your definition from a previous course, right? And then once you did that, then you raise both sides to a power that's equal to the index. So that's how you got the variable y by itself. The other way was to leave it as this rational exponent. And again, you want to solve for y, right? So right now you have y to the 1/3. You don't have y to the first power. So I need this exponent to be a 1, not a 1/3. So what you did was this. So to get this to be a exponent of 1, you raise both sides to a power that is equal to the reciprocal of 1/3, the exponent. The reciprocal of 1/3 is 3, right? So you're going to raise both sides to the third power, just like you did here. See that? Watch, just like you did here. And then you're going to use the power of a power rule, so you can multiply exponents. So 1/3 times 3 is 1, so you get y to the first equal 0. And that's what we had here. Okay? All right, so just remember these two things. All right, and for this one, I'm going to go ahead and for this one right here, I'm going to go ahead and leave it as a rational exponent. Okay, so I get y to the 1/3 equals 1/2, right? Okay, so I want to solve for y. Right now I have y to the 1/3. So I need this exponent to be a 1. So one way you're going to do that is you're going to raise both sides to a power. So this exponent has to be the reciprocal of this exponent right here. So the reciprocal 1/3 is 3. So I'm going to cube both sides just like it did here. And so now I have a power to a power rule. And so I'm going to multiply those exponents. 1/3 times 3 is 1. So I get y equals, and then 1/2 to the third power. Remember, 1/2 to the third power, if you got to write it down, you write it down if you need to. 1/2 to the third power means 1/2 times 1/2 times 1/2. So 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. So I get 1/8. And there's your answer. Those are the solutions to the original equation. Okay? All right, now as long as you did the algebra correct, as long as every step was correct, then these should be your solutions. All right, so that's number 2. So it's not a difficult process. It's just remembering some things that you've learned in the past. For one of them being how to solve a quadratic equation by factoring, and in number 2, we had to remember some ideas about rational exponents. Okay, let's look at number 3. So number 3, let's say we had this one. So we have y to the 2/3 minus 16 equal 0. So y to the 2/3 minus 16 equals 0. So that looks pretty complicated for most of you. But it really is not. If you go ahead and you think about that substitution, trying to get a quadratic equation, it's fairly simple. So let's look at this right here. So I want you to think of y to the 2/3 as this. So do y'all agree that, and again, I'm going to be using some properties of rational exponents. So do y'all agree that y to the 2/3 I can write as y to the 1/3 squared, right? So you see that? Y to the 1/3 squared. And so remember, the reason why I want to write it like this is because I want to get a quadratic equation. So if I'm going to get a quadratic equation, I need that variable, that base, to be raised to the second power. And so now what I'm going to do is I'm going to let u equal y to the 1/3. So let u equal y to the 1/3. And once I do that, notice what happens. So I'm going to go ahead and rewrite this using this now. So watch, I'm going to have y to the 1/3 squared minus 16 equals 0. And so I'm going to rewrite y to the 1/3 as u. So I get u squared minus 16 equals 0. And notice I have this quadratic equation. You see that? Very simple, right? So this is the difference of two squares. I can factor this using the difference of two squares. So I get u minus 4, u plus 4 equals 0. And then setting each factor equal to 0, I get u minus 4 equals 0, u plus 4 equals 0. And then solving these linear equations, I get u to be 4 and u to be negative 4. But remember, be careful. You think as you go through the process, this right here are the solutions to this quadratic equation that had the variable u. My original equation had the variable y. So I got to come back and resubstitute. So remember, u was this, y to the 1/3. So y to the 1/3 equals 4. Y to 1/3 equals negative 4. And you remember you're solving for y, right? So I need to solve for y. So right now, this is the exponent 1/3. I need that to be a 1. So let me go ahead and rewrite this over. And just like we did in the previous problem, we're going to raise both sides to a power that is reciprocal of this exponent right here. Okay, so if I multiply the exponent by its reciprocal, remember power of power, you multiply exponents, I'm going to get a 1. So, but you got to do the both sides. So we get to do the both sides, just like this. And so y to the 1/3 raised to the 3rd power, 1/3 times 3 is 1. So I got y equal 4 to the 3rd power. Now use your calculator if you have to. So many of you know, or almost all of you know, that 4 to the 3rd power means 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64, right? But if you need to always check and have a calculator available. That's 4 to the 3rd. Calculator available, go ahead and do it. So 4 raised to the 3rd power equals 64. Okay, over here, 1/3 times 3 is 1. So you got y equal. And then negative 4 to the 3rd power. Now be careful there. So let's put that in parentheses. So negative 4, negative 4, close parentheses, raised to the 3rd power equals negative 64. All right. So if this was an even power, by the way, you're going to need parentheses. Now, if I mistakenly left the parentheses off here, it would not matter because it's being raised to the 3rd power. It's being raised to an odd power. But if that was even, if that was an even power, you would have needed parentheses because any negative number raised to an even power is always positive. But this is odd, so that's why you had negative right here. So these are your two solutions. All right, so the solutions to this original equation is this. Now, let me just show you. If you wanted to check this, which you did not have to, by the way, but if you wanted to check using your calculator, here's what you're going to do. So let's check the first one. Check y equal 64. So let me just show you how to do that. So you always go back to the original. Always go back to the original. So here's the original right here. So y to the 2/3 minus 16 equals 0. So in place of y, I'm going to substitute 64. So I get 64 raised to the 2/3, just like this, minus 16, and I want to see if that's going to equal 0. So on your calculator, here's what you would do. 64 to the 2/3. So put that in parentheses, 64, close the parentheses, raise it to, now see this is a fraction, right? 2/3 is a fraction, so make sure you put that in parentheses. You have to put that in parentheses, just like this. 2 divided by 3, close, and then minus 16, subtract 16 and press equal, you better get 0. And I get 0. Okay, so 64, I did the work correct, so 64 is the solution. Let's check the other one. That's y equals negative 64, negative 64. So y to the 2/3 minus 16 equals 0. So in place of y, I'm going to substitute negative 64. Again, make sure you put that in parentheses. So negative 64 to the 2/3 minus 16, and you want to see if that's going to equal 0. So in parentheses, put negative 64, close the parentheses. You're going to raise it to the parentheses 2 divided by 3, close the parentheses, subtract 16, press equal. Oops, let me do this again. All right, so let's see. Let me do this again. So negative 64, close the parentheses, raised to the 2/3, 2 divided by 3, close the parentheses, minus 16 equal, and I get an error. So let's think about this for a moment. Okay, so we're getting this domain error, right? Now, just be a little bit careful. Don't assume that this solution, negative 64, is not an actual solution. So be a little bit careful. In this particular calculator, and in probably many calculators, when raising a negative number, to an exponent that's not an integer, it will give you an error. So, for example, for this calculator, if you have a number raised to a fractional exponent, so this exponent is not an integer, then this number will need to be positive. Okay? If this number is negative and you're raising it to a fractional exponent, it is going to give you a domain error. But what I want you to remember is this. Let's go ahead and rewrite this using one of our properties of exponents. So for example, see where we have here a raised to the m divided by n is defined to be the nth root of a to the m. So what I want to do is use this property here. So this right here is defined to be the cube root of negative 64 all raised to the second power, right? Okay, so let's use our calculator with this one now. And so instead of using this notation, let's use this notation. I want to show you what's going to happen. So what's going to happen is this. So to put this into this particular calculator, I'm going to have to put parentheses first and then the cube root. So I've got to type in 3 first and then second, and then you can't see it very well, but it's that the x root right here. I don't know if you can see it right here. See how it shows up right here? Okay. Negative 64, then close the parentheses, and then that's being raised to the second power. And I want you to see what's going to happen in this case. So when I do that, I get 16. So I don't get that domain error. I get 16. So I get 16 minus 16, which is 0. Okay, so this is actually a solution. So just remember, your calculator probably, if you get a domain error, your calculator probably requires that if you're going to raise a number to a fractional exponent, then that number will only be defined on your calculator if this is a positive number, okay, or 0. All right. So be a little bit careful with this. I'm glad I actually checked this just to because I forgot about that myself. Just to see the difference between writing like this and writing like this in your calculator. Okay. All right. So in number so that was number I can find it real quickly. That was number 3. So number 3, these are your solutions. Okay. And don't forget, be careful when using your calculator. Sometimes you'll get a domain error when in fact it's actually a solution. It's just the way your calculator calculates things that forces certain things to be a particular number. Okay, so that was number 3. So let's go ahead and look at number 4. So number 4, so it's not difficult, right? So using substitution is not a difficult process. So number 4, let's say we had this. We had 3x to the negative 1 minus 8x to the negative 1/2 plus 4 equals 0. Okay, so just like we talked about before, I'm going to go ahead and rewrite this over. Just like we talked about in previous example, it is always best to let u equal that middle term, that variable expression right here. Okay? Now, Remember, this is pretty difficult to look at and solve, right? So if I can rewrite this as a quadratic equation, then it's going to be fairly easy to deal with. So let's go ahead and let u equal x to the negative 1/2. And remember our process, very simple. Once I do that, remember I want to get this to be quadratic in form. So at some point I got to have an x squared, right? So let's go ahead and square both sides. So I'm going to rewrite this over to show you what's going to happen. So when I square both sides, just like this, I get u squared equal, remember, a power to a power. You're going to multiply those exponents. So negative 1/2 times 2 is a negative 1, which, see this right here, is this, right? All right, and so therefore, all we got to do is resubstitute. So I get 3u squared, because x to the negative 1 is u squared, right? Minus 8, and then x to the negative 1 is u, plus 4 equals 0. And so now let's go ahead and factor this. So you see this is now quadratic, so I'm going to solve this quadratic equation for the variable u. But remember, we eventually want to solve for the variable x, so I've got to come back to this. All right, so here we go. So let's go ahead and factor. Those examples we're going to use will be factorable. Of course, if you're having difficulty factoring this, then use the quadratic formula. So I get 3u minus 2. I think that's going to be the one that's going to work, and u minus 2. So let's double check. 3u times u is 3u squared. The outer is a negative 6u. The inner is a negative 2u. And add them up, I get negative 8u. And negative 2 times negative 2 is a positive 4. Okay, so I'm going to set each factor equal to 0 using the zero factor property. And now I'm going to solve each of those linear equations. So I get 3u equals 2, and u is 2/3. Over here, I get u equals positive 2. So these are the solutions. Now be careful. Those are the solutions to this quadratic equation with the variable u. But I want to solve for the variable x. I got to come back and resubstitute. So u, remember, was x to the negative 1/2. So I get x to the negative 1/2 equals 2/3. And then x to the negative 1/2 equals 2. All right, and now I'm going to solve for the variable x. Okay, so you got to remember some things about a previous course regarding negative exponents. So remember, a to the negative m, so you want to make that exponent positive, right? So you got to remember that if the exponent is negative, you're going to take the reciprocal of the base. So the reciprocal of a is 1 over a. You're going to raise it to the m power. So to make that exponent positive, you take the reciprocal of the base. So the reciprocal of a is 1 over a. Raise it to m power. And then 1 to the m is 1. A to the m is a to the m. Okay? So what that means is this. X to the 1/2 is defined to be 1 over x to the 1/2. Now be careful. A lot of students seem to think that to make this exponent positive, you take the reciprocal of what you see. You got to be careful. All right, so don't think that. So x to the negative 1/2, based on what we just said, to make that exponent positive, you take the reciprocal of the base. The reciprocal of the base is 1 over x. I get 1 over x to the 1/2, right? So 1 to the 1/2 is 1. X to the 1/2 is x to the 1/2. So that's what you see here. All right. Don't think. The point being, don't think that to get that exponent to be positive, you take the reciprocal of that whole term. It's just reciprocal of that base, and then raise the numerator and denominator to that positive power now. Okay, so we get this. Okay, same thing here. X to the negative 1/2 is defined to be 1 over x to the 1/2 equals, I'm going to write this as 2 over 1. Just like we did it before, we can cross multiply, right? So 2 times x to the 1/2 equal, and then 1 times 3 is 3. Now to solve for x, I got to divide both sides by 2 first. So I'm going to divide both sides by 2. Okay, so I get x to the 1/2 equals 3/2. And then remember, you got to now solve for x. So we now have x to the 1/2. To get that exponent to be a 1, I'm going to go ahead and rewrite this over. I'm going to raise both sides to a power that is the reciprocal of the exponent. The reciprocal of 1/2 is 2. So now 1/2 times 2 is 1. So I get x, and then 3 halves squared. 3 times 3 is 9. 2 times 2 is 4. Okay? All right, so that's what I get so far. Now let's go ahead and do this one here. So cross multiplying, I get 2 times x to the 1/2 equals 1 times 1 is 1. And then divide both sides by 2. I get x to the 1/2 equals 1/2, right? Divide both sides by 2. Make sure you saw that. Now I'm going to raise both sides. I'm going to raise both sides to a power, because remember, you want this to be x to the, you want to get x to the first power. So in order to get x to the first power, I got to raise both sides to a power that is reciprocal of this exponent right here. The reciprocal 1/2 is 2. Once I do that, 1/2 times 2 is 1, and then 1/2 times itself is 1/4. Okay? All right, now, something you got to remember, and this is important. You have to remember that when you raise both sides of an equation, to an even power, you may introduce extraneous solutions. Okay, so remember that when you raise both sides to an even power, which I did, you see that? So these may be, one of these or both of these may be extraneous solutions. So extraneous solutions meaning false solutions, meaning solutions. So these are solutions to this equation right here, but it may not be solution to the original. So you have to check. So these may be false solutions. So you got to check. All right, so let's go ahead and check. There is no option here. You have to check. That's important. You have to check. So when you raise both sides to the even power, you have to check, because these right here may not be solutions to the original. Okay, so let's go ahead and check. Again, no option. You have to check. All right, so check x equal -1. X equal 9/4. So go back to the original. I'm going to write the original here, just like this. Okay, all right, now, so let's go ahead and use our calculator just like we saw before. And if I get a domain error, which I should not, because both of those are positive. All right, so I should not get a domain error. So let's go ahead and actually substitute those. I get 3, 9 divided by 4 to the -1 minus 8. So wherever I saw the variable x, I'm substituting 9/4. So 8 times 9/4 raised to the -1/2 power plus 4 equals 0. All right. So I shouldn't have an issue here because that base is positive. All right. So let's see what we get. So use your calculator carefully now. All right. So that's important. So make sure you use your calculator as it should be used. So 3 times 9 divided by 4. Notice I put parentheses there. Raised to the -1, just like that, see it? Minus 8 times, parentheses, 9 divided by 4, close the parentheses, raised. Now this time, I have to use parentheses because that's a fraction. You must use parentheses. You must use parentheses for that -1/2 because that's a fraction. I did not need it here because I was an integer, but I needed it here because that's a fraction. -1 divided by 2, close that parentheses. Then I'm going to add 4. Hopefully that's going to equal 0. And it equals 0. So 9/4 is a solution. Okay, now let's check x equal 1/4. So we go back to the original, just like I did earlier, right? Okay, so 3 times 1/4 to the -1. So where's the variable x? I'm substitute 1/4 minus 8 times 1/4 to the -1/2 plus 4 equals 0. So using your calculator, make sure you put it in correctly. 3 times 1 divided by 4 raised to the -1 Notice I did not need parentheses here because that was an integer, that exponent. Minus 8 times, parentheses, 1 divided by 4, close the parentheses, raised to the, I do need to put the exponent parentheses. I do need to put the exponent parentheses because that's a fraction. Raised to the negative 1 divided by 2, close the parentheses, then add 4, and we get 0. All right, so all of this is 0. Okay, so that one works as well. Okay, all right, so just like this one was 0, so that one works and that one works. So those are your two solutions. So I did not have any, so there are no extraneous solutions. I want you to see that. No extraneous solutions here. Both of those are solutions. So remember, when you raise both sides to an even power, you may introduce extraneous solutions, so you have to check. So these are both solutions. All right? Okay, so let's look at number 4. Number 5. So number 5, we have this in number 5. So let's see what we have. So here's number 5. So this would be the last one we're gonna do. We have x to the 1/3 minus x to the 1/6 minus 2 equals 0. So let me go ahead and write this over. And so remember what we talked about. We're going to let u equal this variable expression right here. So x to that power. When I do that, I want you to see what's going to happen. So remember, the whole point is to use substitution, and so we can try and get this equation that's quadratic in form. So it looks pretty complicated the way it's written, but if I can make it look like a quadratic equation, then I know I can easily factor it. So if I let u equal this, so I've got to square this now. So I'm going to write this over. And when I square it, notice what happens. I get u squared equal 1/6 times 2 is 1/3, right? 2/6, which is 1/3, which is what I see here. So this becomes u squared. So I get u squared minus u, x to the 1/6 was defined to be u, minus 2 equals 0. And now we have this quadratic equation. So let's go ahead and factor this. So when I factor this, I'm going to get u minus 2, u plus 1 equals 0. And then setting each factor equal to 0, I get u minus 2 equals 0, u plus 1 equals 0. So I get u to be 2 and u to be negative 1. Now remember, these are the solutions to this quadratic equation. But I want to solve the original equation which had a variable x. So I got to resubstitute now. So I get x to the 1/6 equals 2, x to the 1/6 equals negative 1. All right, so I want to solve for x. So remember, I want to get x to the first power, right? So we now have x to the 1/6. So we're going to raise both sides. We're going to raise both sides to a power, and that power, that exponent is going to be the reciprocal of this exponent right here. So the reciprocal of 1/6 is 6. And that's the only way I can get this to be exponent 1. 1/6 times 6 is 1. So 2 to the 6, if you use your calculator if you have to, 2 raised to the 6 is 64. Okay? Over here, let me go ahead and rewrite this over. Doing the same thing, raise both sides to a power that is equal to a power that will make this product 1. So the reciprocal of 1/6 is 6. So we're going to multiply. We're going to raise both sides to the 6th power. 1/6 times 6 is 1. So I got x to be, and negative 1 raised to the 6th power is a positive 1. All right. Now, remember a while ago we stated this. That's important to remember. When you raise both sides of an equation to even power, you may introduce extraneous solutions. So right here, I raise both sides. I raise both sides to an even power. Okay, so one of these may be extraneous. So you have to check. So if it's extraneous, it's not a solution to the original equation. So you have to check. So let's go ahead and check this. Let me go ahead and check on a separate sheet of paper. So let's check x equals 64. So go back to the original, and here was the original, right here. That was the original. So I'm going to go ahead and rewrite this over. X to the 1/3 minus x to the 1/6 minus 2 equals 0. Now, I shouldn't have to worry about getting that domain error because 64 is a positive number. So I can easily use the calculator. So 64 raised to the 1/3 minus 64 raised to the 1/6 minus 2. And I want to see if that's going to equal 0. So let's use the calculator. So 64, and if you want to put 64 in parentheses, you can. It's not necessary. But 64 raised to the, now 1/3 is a fraction, so I must put that in parentheses. I'm putting 1/3 in parentheses. Okay? And then minus 64 raised to the 1/6 is a fraction. Got to put that in parentheses. 1 divided by 6. And then subtract 2, press equal, and you get 0. So this is 0, and 0 does equal 0. So 64 is a solution. Okay? I'm going to go ahead and box it off. So 64 is a solution. Now let's check 1. So I'm going to check x equal 1. So go back to the original problem, which is what I'm writing. And where we see the variable x, I'm going to substitute, I'm going to substitute right here, 1, right? Substitute 1. So I get 1 to the 1/3 minus 1 to the 1/6 minus 2, and I want to see if that's going to equal 0. Now, I don't need a calculator here, right? Because the base is 1. 1 raised to any power is 1. So I get 1. 1 to the 1/3 is 1, minus 1 to the 1/6 is 1, and then minus 2. Well, look at this. Be careful. 1 minus 1 is 0, right? And then 0 minus 2 is a negative 2, and a negative 2 does not equal 0. So x equal 1 is extraneous. Okay? So x equal 1 is extraneous, which means that I'm not going to use it. So the only solution, so this is extraneous. So the only solution is x equal 64. All right? Okay, so that is quite a few problems we looked at, but all these problems helped you to see what you had to remember from some previous. Let me try and get the other sheets. Some previous prerequisite skills that were needed. All right. So the main purpose of these examples was to show you that there are types of equations that if you use substitution, you can write it in quadratic form. All right. And remember, though, there are quite some properties from previous lessons and previous courses that you have to remember in order to do some of these equations, in order to solve some of these equations. Okay, so that is the end of this lesson.